Very good morning, dear students. Welcome to the e-learning class. So in our previous classes, we studied about the trigonometry and uses of the trigonometries. Okay, how to use the trigonometry in our daily life. Okay, and we recall some basic terms and some terminologies related to trigonometry. Okay, for example, we learned about the T ratios, or called trigonometric ratios. Okay, so we learned about how many trigonometric ratios? Can you tell me? Yes, very good. Okay, there are 6 trigonometric ratios. For example, sine, cos, tan, cot, sec, cosec. Okay, and you also learned how to find these values and what are the values of, like, what is the value of sine 30? Okay, do you know what is the value of sine 30? Yes. Exactly, it is 1 by 2. What is the value of cos 45? Yeah, very good. It is 1 by root 2. And what is the value of tan 45? Yes, tell me. Yes, exactly, it is 1. Okay, so we will use these uh, formulae or these values in our in our upcoming the questions. Okay, so let's start. So let's see what are the situations in which we can use these trigonometric. Okay, let's see. There is a situation. So can you see there are 3 objects which are flying, or we can say sailing. Can you name? Yes, first one is aeroplane. Okay, second one is a bird, and third one is a ship. So if you look closely, so you can find that this aeroplane is above the boy's eyesight. This bird is in the line of eyesight, this boy, and this ship is downward. Okay, now how will we use the trigonometric here? Let's see. So a bird is flying, so he can see bird directly, but ship is, to see ship, he should see downward. So it is called height and distance. We can find height and distances using trigonometric ratios. Okay, let's see one example. So it says a kite is flying at a height of 60 meter above the ground. The string attached to the kite is temporarily tied to a point on the ground. The inclination of the string with the ground is 60 degree. Okay, first let's read what is written in the example or situation. Find the length of string assuming that there is no slack in the string. Okay, so now what you have to do, you have to visualize this situation in form of geometrical figure. Okay, so let's see how can we visualize this one. Yes, a kite is flying at the height. Kite, where is kite flying? Its height of 60 meter. So it is vertically opposite to the ground. So we can say like this. This is a string and this kite is tied to the string. And this is the height. It is the height of the ground and we measure it vertically. So it is 60 meter. Now this is a string and there is no slack. Okay, look at this word, no slack, means it is not loosely tied, and it makes an angle 60 degree with the ground. So here if we join, this is ground and this is the string, so it makes angle 60 degree. Okay, so this is the angle 60 degree. So this is our figure and there is no slack and we have to find the length. What we have to find? This length. Now we will name this figure. Yes, so what is the meaning of no slack? Look here, this kite has no this string has no slack, but this string has slack. Okay, so it is, you can say it is loosely loosely tied with the ground. So we will use the first one and we will not use this one. So this is our figure, and now we have to find the length of string. So this is the geometrical figure of the situation which is given to us. So we can name this one as A, B, C. Okay, you can give any name to a triangle. So we write this one as A, B, C, where angle B is 90 degree. I think now you are seeing something. It is similar to which figure? What it represents? Can you tell me? Which triangle is this? Yeah, very good. This is right angle triangle. Okay, and we know very well that in trigonometry we use right angle triangle. Okay, because we can use the trigonometric ratios in right angle triangle. So this is our triangle and we need this side. Okay, so here is solution. Let A be the kite. So this is the kite. AC be the string. So AC is the string which is straight. Okay, it should be a straight. And AB be the imaginary line segment representing the altitude of A above the ground. So this is the altitude of kite. Now AB is equals to, it is 60 degree or 60 meter. This height is 60 meter above the ground and the angle is 60 degree. Angle ACB equals to 60 degree. Now we can assume AC as x. So AC equals to x meter, and this is our triangle. Now which ratio we will choose here, because we have sine 10 cos 10 sine 10 cos 10 cot 6 tr 6 t ratios. Okay, so which will we use here? So look here how to choose the value. What we have to find? AC, and what is given to us? AB. We have to choose side. Okay, so AC and AB. So we have to find the ratio of AC and AB, or we can check AB upon AC. Now look at the triangle. This is angle, and what this side is called? Yes, student, tell me. What is the side called which is opposite to angle? Yes, good. This is called opposite side. Okay, and which side is this? AC. What we call, and AC is the opposite to 90 degree angle. So this side is called, yes, very good. Okay, very good answer. So it is called hypotenuse. Now we have AB upon AC. We need, so AB is opposite side upon AC is hypotenuse. And which ratio is equals to opposite upon hypotenuse? Very well, it is sine, and angle is 60 degree. So sine 60, it is equals to sine 60 degree. That's why we pick sine 60 degree to solve this question. Okay, so this is our question. Now we can put the values here. AB is given 60 upon AC is given, yes, it is x. Now we will put the value of sine 60 degree. Can anyone tell me the value of sine 60 degree? Yes, tell me. Yes, very good answer. Sine 60 is equals to, yes, root 3 by 2. So we will put the value as root 3 by 2. Okay, you can also use this one, because sine is, this is our finger, and from here we can check sine. So we know this is 0, 30, 45, 60 and 90. So this is 60. Now from here how many fingers are there? 3. So put root 3 and upon divided by 2. So this is our answer. And after cross multiplication we get the value which is 120 upon root 3. Now we can rationalize this one. You already know how to rationalize. Multiply root 3 on upper portion and then down portion, or we can say multiply root 3 numerator and denominator both. So where it changes into 120 root 3 upon 3, and the answer is 40 root 3. Okay, this is our answer. This is the length of string, or it is approximately equals to 69.20. You can put the value of root 3, which is 1.73. Okay, so here now did you see how did we solve this one? Okay, so let's recall what did we do. We have to find this side, and we are given this side, so we can take ratio as AB upon AC. AB upon AC is opposite upon hypotenuse, and it is equals to which value? Sine, and the angle is 60 degree. Now put the value, it is 60 upon x is equals to value of sine 60, yes, it is root 3 by 2. Now you can cross multiply and find the answer. Okay, so easy, isn't it? Okay. So the length of string is 69.2 meter approx. Okay class, now it's question time. Okay, so use your rough, use your pen, notebook and solve this one. An inclinometer is used to measure. I think you studied about this one in previous lecture. Okay, so you can give the answer and your time starts now. An inclinometer is used to measure dash A, B, C, D. What is measured by inclinometer? Okay students, your time is getting over. Finally the time is over. Okay, so the correct answer is yes, it is B. It measures inclination angle. Okay, now next question is, a contractor plans to install a slide in a park for the children below the age of 5 years. He prefers to have a slide whose top is at a height of 1.5 meter and is at an angle of 30 degree to the ground. What should be the length of the slide? Okay, so let's solve this question. First, what is given? For the children below age of 5 years, he prefers to a slide whose top, this is important line for us, whose top is at a height of 1.5 meter. Okay, so you can see that this is the slide. Okay, it is called a slide. I think you all know this one and all you have used and play with this one. So a children goes upside from here and then he slides from there. So this is again a slide. So this is a slide. This is called height, it is called length of slide, and it makes an angle with ground. So again this figure is again represents which one? Yeah, right angle triangle. A slide whose top is at a height of 1.5 meter. So this is the height of 1.5 meter. Again at an angle of 30 degree to the ground. So this is angle of 30 degree. Now we have to find the length of the slide. So it is something same as the question which we have done in the previous slide. Okay, it is same as the kite problem. So this is our figure. here we have a triangle ABC where angle B is 90 degree. We have to find the value of AC. Let AC be the length of slide. So AC, here you can see the AC, this one is length of slide. Okay, BC be the height of slide. So BC, it is the height of slide from the ground. This is the ground and this is the BC. C is the top of slide. And again BC is given to us, it is 1.5 meter. Okay, now this is triangle in right triangle ABC. So this is our right angle triangle. Here angle B is 90 degree. So this is a right angle triangle. Now we will use the same process which we have followed in the previous question. Okay, how did we solve? Yes, what is given to us, it is BC. What we have to find, AC, and then so it is BC upon AC. Now what is BC? Yes, tell me. It is, yes, good, opposite side. What is AC? What we call AC? Yes, it is hypotenuse. So this is the ratio of opposite upon hypotenuse. Okay, this is the ratio of opposite upon hypotenuse. Now what it equals to? What is the ratio equals? What is the T ratio of opposite upon hypotenuse? Very good. It is sine. So it is equals to sine, and now put the angle which is 30 degree. So yes, this is BC upon AC is equals to sine 30 degree. Now we can put the values. The value of BC is, very good, it is 1.5. What is the value of AC? Yes, AC we have to find, so we can put as AC. Now what is the value of sine 30? So you can use same. Where is 30? This one is 30, so you have to pick this one. Now count from this side. So we have how many left? 1, only 1. Okay, so we can write this one as root 1 upon 2. Answer is 1 by 2. So the value is 1 by 2. Okay, we can use another. If we pick the ratio as AC upon BC, okay, then it is equals to, yes, AC is hypotenuse upon opposite. So this is equals to, do you know? Yeah, very good, very good answer. This is equals to cosec, and it is, and the sine angle is 30 degree. So we can also use this value, this ratio also, but I think you just only need to remember sine, cos and tan only. Okay, that's why we used sine here. So it is equals to 1 by 2, and after cross multiplication we get the value of AC as 3. So what is the length of slide? It is 3 meter. Okay, so length of the slide should be 3 meter. Okay, again let's recall how did we solve. We are given BC, we have to find AC. What is the ratio of BC upon AC? It is opposite upon, yes, hypotenuse, and it is equals to sine. Now the angle is 30 degree. Okay, then put the value and find the answer. Okay class, now again next example. The angle of elevation of the top of the tower from a point on the ground which is 30 meter away from the foot of the tower is 30 degree. Find the height of the tower. Okay, so let's visualize this situation. So again see how will we solve. So this is the tower. Okay, I think you have seen so many towers around you. So this is a tower. Now there is a point on the ground. Okay, so there is a point on the ground, and this point is 30 meter away from the ground, from the foot of the tower. So we can pick this point as C. Okay, so this point is C. It is far, 30 meter far from the foot of the tower. Now it is 30 meter. Yes, and if we connect A to C, then we get the right angle triangle ABC. So this is our figure. Okay, now look here what we are given and what we have to find. We are given angle. Now we are given this side, and we have to find AB. So again, how will we solve this one? So this is our figure ABC, where we have to find AB, BC is given to us, and angle is 30 degree. Okay, so let's see what is the solution. Let AB be the tower. So AB is the tower. Now BC be the distance from the foot of the tower, which is equals to 30 meters. So BC is equals to 30 meter. And again from point C, and the angle C is given to us 30 degree. So in right angle triangle ABC, what is given to us? Okay, so here how will we choose the side? Okay, we have to find, yes, AB, we are given BC. So AB upon BC, just tell me students, side opposite to angle, good, opposite, side which is just along the angle, side along the angle, it is called base, or we can say adjacent side. So it is equals to opposite upon adjacent. Do you know the ratio of opposite upon adjacent? Yes, anyone? Yes, very good. Okay, so it is equals to 10. This ratio is equals to 10, and the angle is 30 degree. So we can use this ratio. So in triangle ABC, we are given AB upon BC, and this is equals to 1030 degree. So let's put the values. What is the AB? It is not given. What is BC? It is 30. What is the value of 1030? Can anyone tell me? Yes. Tell me the value of 1030 degree. Yes, very good. Okay, very correct answer. The value of 1030 is equals to 1 by root 3. Okay, so I think you all you have learned the values of the angle of trigonometric ratios. Okay, trigonometric ratios of the angles. So there is a table, so you have to learn all the table. Not all the table, you just need to learn sine and cos. Then you can find 10, and then you can find the rest t ratios. Okay, so you need to find only 3 ratios. Now it is equals to 1 by root 3. Here if you will cross multiply, so the answer of AB is 30 upon root 3. Again rationalize this one. Yes, so the answer is 10 root 3. Okay students, again question time. In a right angle triangle, cos theta is equals to, and your time starts now. Give the answer. Cos theta is equals to adjacent upon hypotenuse, opposite upon hypotenuse, hypotenuse upon adjacent. Okay class, your time is over. Correct answer is yes, it is A. Okay, here is example 4. A stuntman is climbing a 20-meter long rope which is tightly stretched and tied from the top of the vertical pole to the ground. What is the height of pole? Or an angle is given to U is 30 degree. So this is a vertical pole to the ground, and there is a tightly stretched and tied to the top of the vertical of the pole. So this is a string. Now a stuntman is climbing. So this is a stuntman, I think. So it performs a stunt in a circus. So the length is given, it is 20 meter, and the angle is made is 30 degree. Okay, again we will use this triangle ABC. It is right angle triangle. AB be the pole, so this is the pole, and let its height is h meter. Okay, it is h meter. AC be the tightly stretched rope, so this is rope and its length is, yes, it is 20 meter. In right triangle ABC, so what is given to us? AC. What we have to find? AB. So we have to find AB upon AC. So we will use AB upon AC, and yes, it is equals to sine 30 degree. So it is given h upon 20, and this is equals to 1 by 2. Then our answer is yes, it is 10 meter. Okay, now next question. A tree breaks due to a storm and broken part bends so that the top of the tree touches the ground, making an angle 30 degree. Now let's see. Yes, it is due to a storm. Okay, so you know that storm is too powerful. Okay, like a tornado, it breaks the not only trees, also it damages our house, okay, and many structures. So this is a tree breaks down due to a storm, and then it has two parts. Now this broken part makes an angle 30 degree. So if we can visualize this one as this. Yes, so this is a right triangle, it is making angle is 30 degree. Now distance between the foot of the tree to the point where the top touches the ground is 8 meters. So this distance is given to us 8 meter. We have to find the height of the tree, and this height should be this side and plus this side, because the tree was straight, okay, in the beginning. So we have to add BC and AC also. So we need to find value of BC and AC both. Yes, so this is the total height of tree. Okay, here you can see. So this is our triangle. So we will use this triangle here, ABC. Okay, let's see. Let BD be the height of tree, which is AD, H. So total height of the tree is H. This breaks at the point C, and the top part DC bends and touches to the ground at A. Yes, so it breaks at point C and then touches to the ground at point A. So this is our triangle ABC. Now both sides are equal, AC and DC. Also the distance between the foot of the tree to the point where the top touches the ground is 8 meter. Okay, now DB. It is the total height of the tree, which is equals to DC plus BC. And what is the value of, and DC is equals to, yes, it is equals to AC. So DB is equals to AC plus BC. Now in right triangle ABC, so here we can choose any value because we can find this value, okay, we can find this value or we can find this value. So we can use BC upon AB or we can use AC upon AB. So we can choose any value. Here we are choosing AB upon AC. So AB upon AC, this we are picking. Now what is AB? Yes, tell me. AB is which side? It is adjacent side. What is AC? Yes, very good, it is hypotenuse. So what is the value which T ratio is equals to adjacent upon hypotenuse? Yes, tell me. Very good, very good answer, and it is equals to cos, and the angle is 30 degree. So it is equals to cos 30 degree. Now put the values. AB is 8 meter and AC is not given. And what is the value of cos 30? Yes, it is root 3 by 2. And the answer is 16 upon root 3. This is the value of AC. Now we can find the value of BC by using different ratio. Now we can take BC upon AB. Okay, and this is equals to opposite side upon adjacent, and it equals to 1030. Value of 1030 is same 1 by root 3, and the answer is BC equals to 8 upon root 3. Okay, now we have to find the total length here, or we have to find the value of H, which is AC plus BC. So add both. So you have to add 16 upon root 3 plus 8 upon root 3, and it is equals to 24 upon root 3. Here you can rationalize, and this is our answer, 8 upon 8 root 3. So this is the total height of the tree, which is 13.84. Okay class, now question time. The length of a shadow of tower is equals to the height of the tower and the angle of elevation. Your time starts now. Okay, give the answer. Okay class, your time is over. So it says that this is the length height of tower and this is shadow of tower, and both are equal. Let's say if the length of shadow is 10 meter, then height is also again 10 meter. What is the ratio of 10 upon 10? It is equals to 1, and this is equals to 10 theta. So do you know the value of 10 theta, which is equals to 1? Yes, very good, it is 45. So angle is 45 degree. Now next, from the top of the lighthouse, angle of depression of two ships are 45 and 60 degree. So let's visualize this one. So this is the lighthouse. Okay, I think you know what is the what is the work of lighthouse. Yes, it shows the path to the ships in the night. So here are two ships, both ships are either side of the lighthouse. And the angle of depression, now this is the angle of depression if we look down, so it is called angle of depression. So a people on the lighthouse, he sees both the ships, so this is the angle of depression and it makes angle with horizontal. So the angle are 45 and 60 degree. Okay, now meet the point this ship to the foot of the tower. Okay, and again this is again to the meet to the lighthouse. So here you can see it is making Z. So do you know what does Z represent? Yes, yes student, you are very good. It represents alternate angle and the alternate angles are equal. So again total length is 400. So this is our tower. We have to find the height of the tower. Let AB be the lighthouse of the height h meter. Then C and D be the two ships. So these are the two ships. L be the observer's horizontal line. Yes. BD be the distance between ship D and foot of the lighthouse. So this is BD. It is the distance of a ship and lighthouse. Now the angles are alternate, so this 45 is equals to this angle and this 60 is equals to this angle. So now we will take triangle ABC and find the value. Now in triangle ABD, so we can write this one as AB upon BD because we have to find AB and we are given BD. So it is equals to 1060. Use this one and it is equals to okay. So the answer is H equals to 400 root 3 and divide by 1 plus root 3. Okay, now here you can rationalize this value and multiply root 3 minus 1 on both sides, and this is our answer 203 minus root 3. So put the value of root 3 which is equals to 1.73 and the answer is 254 meter approx. So this is the height of the tower. So hence height of the lighthouse is 254 meter approx. Okay class, now feedback question for you. How do you feel for today's class? And your time starts now. Okay, finally the time is over. Okay, so let's see what did we learn today. So we solved some problems which are related to our daily life. Okay, we use different kind of trigonometric ratios to find height, distance, okay, anything. So what you have to do, you also need to select some questions which are based on this trigonometric problems. Okay, then try to solve by yourself. Okay class, so now time to end the class, and now we will meet in next class with more problems to solve. Okay, so